Okay, grade 12. Uh, I want us to look at this one, right? 2024 November paper one, question 5 of your past paper, physics. So, if this is your first time watching my lessons, guys, please subscribe to the channel, leave a comment, tell me what you want us to do next. Okay, so now when I look at this question 5, it's from November 2024, and question 5. Okay, so we have a constant force F that is applied at an angle of 30 degrees to horizontal on a crate of mass 6 kg that is initially at rest. Okay, and they say this is shown on the diagram, and they tell us that the constant frictional force of 10 newton uh, act on the crate at it move from rest at point 8. Okay, so I'm just gonna include that on my diagram just to see how this looks like. So if the force is moving to the right, this is where my Fk will go, and they say the frictional force is 10 newtons. Okay, so now they say that the distance between point A and B is 1.5. The speed of the crate at point B is 2 meters. Guys, let's work on this. From rest, okay, the weight rest means that the initial velocity is 0. So I'm going to say from rest, my V initial, that's 0 meters per second, because I need to analyze this before I go into answering questions. The speed of the crate at point B, so this is my V initial, which is 0 meters per second, and then V final at B is given as 2 meters per second. Okay, define the term work done by a force. So the work done on an object. So when you define the term work done by a force, you can define that by defining the formula of the work done. We know that if we write the formula down, okay, let me quickly write the formula down. Then I'm going to define the work looking at that formula. If you still remember the formula for the work done, it goes like this. So work done, it's equals to the force multiplied by the displacement and the cos of theta. So when they say on 5.1 and they want you to define the work done, I'm going to say the work done on an object is the product of what? Is the product of the force. Is the product of the force and displacement. Is the product of the force and displacement. Okay, the product of the force and displacement. Okay, and then we say that of is the product of the force and the displacement of what? Of the object in the direction of the displacement. Of object in the direction of displacement. But now, since you're in metric, I'm going to advise you to go open your exam guideline, define it how they want it in an exam guideline. You can say is the work done on an object by a constant force. It's where F is the magnitude of the force, or you can just go to your just go and consult your what is this, your exam guideline. So now they say draw a free body diagram showing all the forces that are acting on the crate as it moves, and this is 4 marks. So I'm going to give you an exam tip. So an exam tip that I want to give you is that since there are 4 marks awarded for this question, okay, this tells you that you should have 4 forces that are acting on this object. 4 forces, because now they no longer give you marks for the component of the force. They no longer give, so no need for you to include the components. So when you write your free body diagram, you're going to say you have an applied force going in that direction. then you're going to have the weight going up, which is force number 2. Force number 3 is going to be the normal force. So the weight, which is Fg, it will go down, and then this is my frictional force. So those are the forces that you need to indicate. So to answer your 5.2, so the 5.2 will look like this. You're going to say the free body diagram with the F applied, and then we have the Fg, which goes down, and then the normal force is going to be opposite direction. Please make sure that you also name your forces, né? And then we're going to have the frictional force. You can call this Fk since it's moving, it's fine. That's your free body diagram. Easy. Collect that format. 5.3. Use energy principles. Use energy principle to calculate the magnitude of force F. Guys, I don't want to go into too much details. I just want to make sure that by the time I finish answering this question, you guys understand everything here. Né? So I'm going to give you the best way to approach this question. There are many ways that you can do, but I always like to make my life simple. So I'll go with the easiest method. Okay, right. I'll go with the easiest method. So the easiest method that I'm going to go with is that they said you must use energy principles. Okay, you must use the energy principle only. We need to use either the work done by the non-consecutive force or the work energy theorem. So let's explain this energy principle only. So the energy principle, the first one, you can use what we call the work done by non-conservative force. Or you can use the work energy theorem. How? Look at this now. So you know what I like to do? I'm going to choose the one that gives me something like an easy way to go. So I'm going to write two formulas for the non-consecutive force, and I'll definitely give you the formula for the work energy theorem. So the work done by a non-consecutive force, it's equals to the change in EK. Then we add this with what? We add this with the change in potential energy, EP. Okay, that's the work. This is for this one, the work done by the non-consecutive force. The work energy theorem, it says that the work done, the total net work, it's equals to the change in EK. It's equal to the change in EK. Right. So these are the two formulas that we can use to solve this. It's up to you which formula you want to go with. So that's up to you. Even if you use one of these formula, you'll still get it right. Okay. So now let me explain the first one, which is the non-consecutive force. So you're going to what you're going to do now, I need you to look at the free body diagram from that question 5.2. And then you need to determine which non-consecutive force that is acting on the crate. And you won't be able to determine the non-consecutive force if you don't understand what is a non-consecutive force. Okay, so now we know that in this case, the work done by the applied force and the frictional force of 10. So I can see that the non-consecutive forces acting on the crate is going to be the work done by the applied force and the frictional force. I hope you guys understand. So let me work on this one. Then it's up to you which method you'll go with. So the work done by the non-consecutive force is equals to the change in EK, and we are adding this with the change in EP. Right. So if you still remember, I'm saying that the work done by the non-consecutive force is going to be the work done by the frictional force plus the work done by the applied force and the frictional force, the Fk. We're going to equate this to the change in kinetic energy, which is 1 over 2 times the mass. Then I'm going to open the bracket and take my V final squared minus my V initial squared. Close the bracket. Then we're going to add this with the change in what? The change in EP, which is mg. Inside the bracket, you need to take the final height minus the initial height. Okay, right. So now I'm going to look at this and see how will this help us. How can this help us to solve the problem? How can this help us to solve the problem? Okay, so now what I'm going to do, I know that this is something like a horizontal force. You need to ask yourself, does this guy have what we call, does this have potential energy? Because since it's a horizontal force, does it have a potential energy? That's what you need to ask yourself. Because the moment you start making a mistake using this, the potential energy, you need to understand what is a potential energy. It's going to be the energy that only the objects that are acting vertical, they will have the potential energy. But this is horizontal. I'm just going to say my potential energy is 0 because of the height. Okay, so we don't have vertical height, so this tells you that this will be 0. But let's say that this thing was moving on an incline. So you can see that if it starts on an incline and this is point A, this is point B. So if it starts from point B, it goes up and they tell you that this is the height. So it starts at the ground, which is 0. Maybe it goes to 5 meters. So you can see that H final is 5 minus H initial is 0. But we don't have, you see, this is how the object is traveling. It's not on incline, it's not moving vertical upward. We don't have potential energy. So everything there will be 0. I hope this makes sense, okay? So if it is on the horizontal, just know that the potential energy is 0. So it will only have the kinetic energy. Okay, I hope you guys understand that part. So now, when I do this, when I do the substitution, I need to find the work done by the applied force. Okay, so the work done by the applied force, I'll say F times the delta X, the cos of theta. Then I need to add this with the work done by the frictional force, which is Fk, the delta X, the cos of theta. We equate this to half mass into Vf squared minus V initial. Remember, plus 0, so it's just 0. This is what I'm going to do. But when you write your equation, there's a mark for this equation. Just make sure that you write everything in that form. Now, let me do the substitution, and I'm going to move easy with you guys on this one. We are looking for F. So we don't have F. The displacement, look at the displacement. The direction of the motion is 1.5, is going to travel 1.5 meters. Then I'm going to sub in that delta X as 1.5. Then the cos. So now when I use the cos, I'm going to use the cos that is between the displacement and the F applied, which is also one of the most important things that you need to understand. So this is my displacement. Okay, this is my delta X. So the angle on that cos is the angle between the applied force and the displacement, and it's given as 30. Please make sure that you understand that part. So it's given as 30, so this tells me that this will be the cos of 30 degrees plus Fk. The frictional force was given as 10 newtons. I'm going to substitute 10 newtons. Right, so this will be 10. Right, the displacement is the same because we're going to move a distance of 1.5 meter. But now let's talk about the angle of theta for the kinetic friction. Okay, so let me draw this down so that this can make sense. Whatever that I'm going to explain, it is going to make sense. We are moving from point A to what? To point B. Right, we are moving in that direction. That is the direction of the displacement. And now, where is friction going? Friction is going in an opposite direction. What is that telling you? Frictional force will have a negative work done. So it is going in an opposite direction as the displacement. And what is the angle between the displacement and the frictional force? 180. Angles on a straight line, that's 180. Let me give you an example. Let's assume that in this case, the applied force was not applied at an angle. It was applied horizontally to the displacement. Let's say this is what I have. Delta x. You know, when I teach, I don't like to do example. I don't like to put example for something that is not even on that paper, but it's fine. Let me make sure that you understand what I'm going to do here. So look at this force. It is in the same direction as the displacement. What will be the work done by F? It will be F delta x, the cos of theta, which is equal to the F, then delta x. I want to show you guys theta. This will be the cos of the angle between the force applied and the displacement. It's 0 degree, so it will be 0. So to conclude this, if the force is parallel to the displacement, the angle we use 0. If the force is going in an opposite direction as the displacement, we use 180. And if the force is applied at an angle, you substitute that angle. I hope this makes sense. Now, let's go back to the question. I'm going to substitute. We said this will be the cos of 180 degrees. Oh, okay. 180 degrees. So this will be the cos 180 degrees. Then this is equal to 1 over 2. What was the mass of this? 6 kg. Né? So this will be 1 over 2 into 6. Close the bracket. V final, we start at 0, we end with 2. So the V final is going to be 2 squared. We minus the initial, which is 0 squared. So now, the only thing that you can do, you need to make F subject of the formula. And I'm going to approach this according to what my math teacher used to tell me, that when you work with these problems, especially in physics, do not round off, only round off the final answer. So I'm going to teach you guys how I avoid rounding off. So I'm going to write this as half, right? And then this is multiplied by 6. This is 2 to the power 2. Then I take this part, everything there, I put it this side, it's negative. So I'm going to put that inside the bracket as 10 into 1.5, the cos of 180. I'm going to put it inside the bracket because then everything there will be negative. Then now I can divide both sides by that 1.5, the cos of 30, divide everything there by 1.5, the cos of 30. Right, you can also apply the method that you prefer to isolate F. It's up to you which method you prefer. Let me just put that on the calculator and see what I get. I'm going to say this is, on top I have half, which is multiplied by, okay, let's put this half inside the bracket. This is multiplied by 6 multiplied by 4. I'm just going to say 4 because it's 2 to the power 2, right? Then I'm going to subtract everything inside the bracket. I have 10, which is multiplied by 1.5. Close the bracket. 1.5. Okay, this is multiplied by 1.5. Come on. Then close the bracket. Oh, not yet. Let's multiply that by the cos of 180 and see what we get. Okay. Now I can close the bracket. Everything is divided by 1.5, which is multiplied by the cos 30. Guys, please trust me. If you prefer to pass the calculator for each and every step, it's fine. You can do that. But if there's a point where you have to round off, you can avoid rounding off, okay? So it's up to you what you want to do. So this gives me 20.78 if I round it off to 2 decimal places. So my force applied is going to be 20.78 newtons. That's 20.78 newtons. So this is the best way to solve this without having some mistakes of rounding off. Right, I'm going to work this using the network done. This will be a very short one. So I think I can just put it on the other side, okay? Okay, so this was the work done by the non-conservative force. And another energy principle is the work done by the change in EK. So what is that equals to? The net work done. The net work done, we need to find the net work done by F. We added that with the net work done by frictional force. Equate this to the change, which is 1 over 2, and then this will be my mvf squared minus my 1 over 2 mv squared initial. Okay, so you can just say, remember, the work done by frictional force, this will be F delta X. Okay, let me just do this. This will be F delta X, the cos of theta. We're going to add this with Fk delta X, the cos of theta. It's equals to 1 over 2 m out as a common factor. Then I'll say Vf squared minus V initial squared. Let's do the substitution. We are looking for F, right? Then delta, it's 1.5. The cos of F we said is 30. If you still remember, then F, this one it was given as 10, and we said the distance is 1.5. And then this will be the cos of what? This will be the cos of 180. Okay, this is equals to, can I please write this one down here? Just say this is 1 over 2. The mass is 6 into, this will be, we said this is 2 squared minus 0. So I think you can also see that the change in the work done by the network is equal to the change, which is the work energy theorem. It gives us exactly what we have on that step. Okay, it gives us exactly what we have on that step. So you can see that there's no difference. So we have all exactly what we got previously, but now the difference is that don't forget that when you use the work done by non-conservative force, if you don't include this on your formula, everything will be wrong. You're going to lose 1 mark for the formula, right? So I'm not going to waste time on that. You can see that still this one will give us F is equal to 20.78 newtons, which gives us the same thing that we got this other side. I hope you guys understand that part. Okay, the last question, it says that a 2 kg object is placed in a crate. So this is my crate and I need to place a 2 kg object. So I'm not sure, it's like saying placing a 2 kg on top like this, then this is 2 kg. What is the statement saying? What effect will this have on the work done by the same force when the crate is again moved from point A to B? So look at this. We are adding 2 kg block. We need to understand how will this affect the work done. They are not saying how will this affect the force. The work done if we still use the same force. Okay, will the work done increase, decrease, or remain the same? Okay, so you know what I'm going to do? I'm going to say that to answer this question, let me say I know that the work done on an object by that F, it's equal to delta, it's equal to F delta X, the cos of theta. What is this formula telling you? It is telling you that the work done by force F, it depends on the magnitude of the force, the displacement, which is the covered, which is the 1.5 covered, and also the angle. You understand? So the work done, it depends on the force, the displacement, and the angle that the applied force is applied with. So this tells you that when we add the 2 kg block, okay, when we add the 2 kg block on top of that one, this does not change the size of any of these quantities. So this is it depends on the force, it depends on the displacement. So the force, we still have the force as what? 20.75, because they said the same force, and then the displacement is still as 1.5, and angle theta is still as 30 degrees. Okay, so now look at this. By adding the 2 kg block, this does not change any of this magnitude. Therefore, this tells you that the work done by the force does not change. So if the work done by the force does not change, the answer, the correct answer here, it remains the same. And they don't even need a reason for that. But I don't want you to do guesswork and say, today I'll go with increase. I feel like increase is the correct answer. Please don't feel. Just know that this is the correct answer. Work something out. Right. So we're going to say it remains the same because by adding the 2 kg block, this does not change anything. However, it does change something, which is if you know this, the frictional force will change. Why? Because if you add a 2 kg block, if you add a 2 kg block in the crate, this will change what? The magnitude of the normal force. This will change the magnitude of the normal force, and the magnitude of the normal force affect friction. Remember, the frictional force is equal to the coefficient of friction times the normal force. So if the friction increase, the Fk also increase. If the friction increase, let's say if the normal force increase, the friction increase. So you can see that by adding a 2 kg, this affect the normal force, which will also affect the friction. So maybe in the upcoming exam, they might change the question and say, what effect will the work done have on the frictional force? You understand? What will the work done by the frictional force on the crate from point A to B increase, decrease, or remain the same? So you can see that the work will change if they talk about the work done by the frictional force. I hope you guys understand, and I hope you guys really enjoyed this one. I want us to look at the next question. Please make sure that if you have been subscribed to the channel, now is the correct time to click that button. Please subscribe to the channel, guys, and then I'll make sure that you feel at home.